Hey everyone, and welcome to another devlog for my need-based city sim thing I'm trying to make. Last time I gave up on my first prototype because of my struggle to implement something I call the action plan. And this week I want to talk about how I try to start again, but concentrating only on the action plan, ignoring everything else, hard coding, doing the bare minimum, bare bone, throw everything at the wall and see what sticks kind of, prototype. And so after a lot of thinking, I came up with 3 main criteria for my action plan system. The first is that it needs to be composable. That means that the action plan has to be built from many small actions that can be composed together. And these actions could be something like moving a specific distance every frame, or maybe playing a specific animation, or something like spawning an object in the world. Second, it has to be dynamic. And by this, I mean being able to be built from the current state of the world. This is something like choosing to drive or ride a bicycle or walk to somewhere. But it can also mean being updated as it goes on. For example, if the AI is following someone, then the target will be changing every frame, and so it has to recalculate its pathfinding every frame. And third, it has to be interruptible. And this one is really the one that scares me the most. Not so much because it's really hard to do, because I just think it's going to create like an enormous amount of bugs. What I mean by interruptible is that if the AI, for example, was going to grab some food from the fridge, when it opens the fridge, it's realized the food is not there, then it needs to cancel its action and do something else. But it can also be like because of external factor, right? The classic I was talking about before is if the AI is eating in a restaurant and a bomb goes off, it has to kind of stop eating and start running. The bomb in the restaurant thing is going to be kind of a recurring theme, I think. Some of you might have noticed a couple of screenshots from Unity's behavior tree system. And while I think it illustrates what I'm talking about really well, I don't actually think it's solving the issues I have with my action plan. But that's going to be the subject of another video because it's kind of still making its way through my brain. So this time I started another prototype, but this time no fancy UI or JSON struct or system or manager or anything, just a single sprite with an entity script attached to it to prototype the action plan. And I keep it as simple as possible to introduce complexity one thing at a time. And I'm kind of lucky that I have a bit of experience with game development, and so I have a good idea of what kind of complexities I can introduce and how much issues it's going to bring. For example, the most basic one I can think of is just moving, because all entities will have to move, and if you're ignoring pathfinding and collision, it's actually super simple. Another one would be playing animations, and this one can be surprisingly complex. You could have targeted animations, looping animations, single shot, one shot animation. It can be kind of tricky. There's, of course, sound, which is interesting, but can probably be put off until much later. There's stuff like object interaction, like an NPC grabbing a fridge and trying to open the door. This is actually kind of hard to do. Like, a lot of AAA studios still struggle with synchronizing multiple entities' animation together. And as you introduce more complexity, you're going to have to start to introduce a little bit more complex systems like inventory management, maybe day-night cycle. It might seem weird to talk about day-night cycle, but time management is really important. Like, the last thing you want, if your day lasts 15 minutes, is for your AI to spend 20 minutes cooking something, right? Because it doesn't make sense. You have to make sure that all your time scales kind of match together. And that can become really important as you introduce more and more activities that your AI can do. Of course, after that, you have more systems that manages your world. I'm talking about like procedural generation, LOD system, not just visually, but also logically. Like probably when you're not seeing an AI, you don't have to play all its animation. You don't have to calculate as much collisions and stuff that the AI would be doing normally. You can just kind of simplify the action plan maybe. There's a lot of stuff going on with like saving and loading too. And these are all things that usually I would recommend you at least kind of think about it before you start working on something, because it's really hard to add this later. But in my case, I decided to just completely ignore that because it added too much complexity and I needed to really make it as simple as possible, even if I know I'm kind of shooting myself in the foot. With all of that in mind, the first thing I implemented was the walk action. Woo. Yeah, so this one was pretty simple, right? Just move the entity sprite a couple of pixels every frame towards a destination. And because I wanted my actions to be atomic, it kind of felt right to make it a method inside my entity script. So I basically have a go-to method that takes a position as a parameter, and then it moves the sprite a couple of pixels every frame. So the second one I implemented was sleep. Yeah, I know, baby steps. This is basically a method that does nothing because it's just, sleeping. But it did introduce the first bit of complexity, which is now I have to choose between two actions. And to do that, I introduced a new action that I called the default action. And all it did was decide if it should sleep or it should walk. And to do that, I have a parameter called energy that depletes over time. And based on how much energy you have, you walk or you sleep. This kind of introduced the second part of the dynamic thing, which made me realize that action plans and actions are basically the same thing. An action plan is just an action that calls other action, which also fits with the whole method thing, because that's basically what functions and methods are, right? They just call each other. So up till now, things were looking pretty good. I then added cooking and eating. This was the first slightly more complex series of action. One, because for the AI to be able to eat, it first needs to cook, so it introduced some kind of dependency between actions. But also, the eating action was kind of interesting because first it has to go to the food, then it kind of stands on the food for a certain number of time, and then the food has to despawn. So it's like 3 actions for one action plan, right? And any of those actions could be interrupted by something. So this introduces the first idea of being interruptible. Again, the actions are really simple. Cooking is just standing in place, waiting a certain number of seconds, and then spawning an object. And eating is just a go-to, followed by waiting a certain number of seconds on top of the food, and then making the food despawn. But this was working pretty well with the idea of that each of these actions are methods. And so I introduced the concept of having a stack of actions. So I had a list of all the methods that were being called by the action. And I just called the last action in the list. And then this action returns a state, like running or finished. And if it returns finished, then it gets popped from the list. And the next frame we call the previous method that was in the list. This is called a stack. And it was working pretty well. So well, in fact, that I thought I could start making things a little bit more interesting. So I downloaded this awesome free asset pack from Kene, and I started replacing my little square sprites with actual, good-looking sprites. And I tried to add more and more complexity to these basic actions. First, I put a bed, so now the sleep action became sleep in bed, and you had to first go to the bed and sleep in the bed. And I added cooking. You first have to go to the kitchen to cook, and then the food spawn, and then when it spawns, you have to bring it to the table and stuff like that. I even added a little bit of concept of ownership, so that when an AI is eating some food, it's owning it, so no one else can try to eat it at the same time. I added the same concept for the bed. When an AI is sleeping in the bed, it owns it, so no one else can try to sleep in that bed. Which means I could drop multiple AI in the scene, and without changing anything, watch them do different action because, you know, the bed was occupied so the AI would do something else, or the kitchen was busy so that the AI would do something else, or they would decide to eat different types of food or something, I was actually pretty happy. I thought I had maybe figured out the whole action plan stuff. But of course, I figured, well, I need to make sure, I need to push it until it breaks. So I wanted to try to introduce a lot more complex stuff, but that meant bringing in maybe some other systems like an inventory or maybe some time management or something. I had ideas of like the AI going to a market to buy ingredients to cook, for example, and have them put in the fridge so that it would have to pick what's in the fridge to decide what to cook or something like that. Or maybe the two AI agent, one is a teacher, one is a student, and they have to go to school, and the student has to sit at the student desk and the teacher has to sit at the teacher's desk, and they have to teach each other, and it has to happen, of course, at the same time. And I'm gonna tell you right now, it didn't take very long before things started to break again, and I had to kind of start refactoring the whole concept. But that's going to be for the next episode. So until then, see you all. Bye!